In this video, we're going to begin section 3.4.4 on the differentiability of a function of two variables. Definition 3.4.5. A function f of xy is called differentiable at a point ab if two things. First of all, its partial derivatives need to exist at ab. And secondly, f may be expressed as f of x equals f of ab plus f sub x of ab times x minus a plus f sub y of ab times y minus b plus a function e of xy. Now that's not it. There has to be also the condition that the limit of this e of xy over a square root of x minus a squared plus y minus b squared, that limit as xy goes to ab must be 0. Now that's a lot to unpack and understand why this definition makes sense. So how can we make good sense of this? Well, the first thing to do is to notice that we can rearrange this equation up here, and if we solve for e of xy, if we send everything in front of e of xy to the other side, then we can solve and get e of xy is equal to f of xy minus this. If we look at that difference, we can interpret e of xy as the difference between the function, and we've seen this before. That's exactly the expression that is the tangent plane. So it's the difference between the function value and the tangent plane value if the tangent plane exists. In other words, e of xy is giving us a measure of the error, e for error, in using the tangent plane as an approximation for the function. Now that's only the first part. What about this limit? Well, the numerator we just said is a measure of error. What about the denominator? The square root of the sum of two squares. And that we should recognize as the distance formula. That is the distance from a point xy to a point ab. And if that limit as xy approaches ab, if that limit equals 0, that means that the numerator and the denominator, well, the numerator must be approaching 0 faster than the denominator does, which means that as xy approaches ab along any path that you should choose, remember these are limits in R2, as xy approaches ab in two-dimensional space, the error term must go to 0 faster than the point xy is approaching ab. If that is the case, then the function is differentiable. So in the next video, we will do an example where we will actually apply this definition to show that a function is differentiable at a given point.